transformation of the unit is rotations. So rotations, this is when a shape spins around a central point. Our central point in every single one of our examples is going to be our origin, or that very center of our x and y axis. And we're going to cover 4 angles of rotation. One is 90, 180, 270, and 360. When we talk about the direction of rotation, we have 2 options. We have clockwise, and we have counterclockwise. So there's a few cool things about rotations. The first thing is that every 90-degree turn, the x and y coordinates switch places. So if A is x comma y, after we rotate 90 degrees in either clockwise or counterclockwise, those 2 numbers actually switch places. And then 90 degrees, they switch back. And that pattern continues over and over and over again. The 2 shapes are congruent after a rotation. So once you rotate it, it's exactly the same. And the distance from the center of rotation to the old and new points remain equal. So let's kind of take a look at this. I've got quadrant 1 up here, quadrant 2, quadrant 3, and quadrant 4. So if I have my point A up here in quadrant 1, and let's say it's at 2, 5. So A is up here in 2, 5, it's right here. A 90-degree rotation is going to land it 1 quadrant away from where it currently is. So if we go clockwise, it lands in quadrant 4. If we go counterclockwise, it lands in quadrant 2. 180 degrees, doesn't matter which direction we go, it lands it in the very diagonal quadrant over here. The same is true if A actually started over here. So if this was A, 90 and 90, or 180. What our coordinate point ends up looking like is this. So up here A is 2, 5. When it gets rotated to this quadrant right here, it becomes 5, -2. So the 5 and the 2 have switched places. And then in quadrant 4, all y's are negative, so that's why the 2 is negative. Up here in quadrant 1, nobody is negative, therefore no numbers are negative. We repeat another 90 degrees right here. So we went 90, here's another 90. We're back to having 2 and 5 in that order, but they're both negative because in quadrant 3, everybody's negative. Another 90 degrees. We're back at 5, 2. And in quadrant 2, x's are negative. So with these 90 degrees over and over and over again, this pattern repeats itself. 2, 5, 5, 2, 2, 5, 5, 2, 2, 5, 5, 2. Over and over and over again. Which number ends up being negative is all dependent on which quadrant you're in. So if you're in 1, nobody is. Ooh, excuse me. Quadrant 2, only the x's. Quadrant 4, only the y's. Quadrant 3, everybody. Then, if we go diagonal in either direction, that's the 180 degree rotation. So let's try it. So we're going to plot the point Z, 3, 5. So Z's right here. I'm actually going to put it in black font because we've got it written in black over here. Okay, so Z is 3, 5. We're going to rotate it 90 degrees counterclockwise, and that's going to have us arrive at Z prime. So 90 degrees counterclockwise. So the 90 means one quadrant over. So we're either going to be in quadrant 2 or quadrant 4. But counterclockwise means we're going to go this way. So Z is going to be in quadrant 2. In quadrant 2, all x's are negative, so we've got a negative and a positive. Then every 90 degrees, we're going to flip the order of these numbers. 5, 3. And just like that, we've got Z prime. Let's say we want to rotate 180 degrees to get to Z double prime. I don't have to specify clockwise or counterclockwise because either way, Z double prime is somewhere down here in quadrant 4. In quadrant 4, y's are negative, so it's going to be plus and minus. And then because 180 is 2 90s, the order of our points have switched, but then they have actually switched back to being 5, 3. So Z double prime is right there. So if it helps, up here you see that Z is 3, 5. You can go, all right, this one's 5, 3, 5, 3, 3, 5. That pattern will be true about any single problem that you see. So even if we're going to plot an entire shape like this, all right, bring the graph down here. A is at 2, 5. 2, 5, right there, A. I should do this in black because my prime points are going to be in red. A. We're going to change C to be 4, 2. Right there. C. B is negative 4, negative 2. So there's B. So we've got this triangle right here. It doesn't matter which point we start with. We're going to rotate each point individually. So right now, A is in 1, C is in 1, B is in 3. "90 degrees clockwise has us rotating our points like this. So A is in quadrant 4. C is in quadrant 4, and B is in quadrant 2. Using our quadrants, we're able to assign the positives and negatives. Y's are negative in 4, X's are negative in 2. And then what I'm going to do, just for my own practice, I'm going to draw a graph like this. So right now A is 2, 5 right here. So it's 5, 2, 2, 5, 5, 2. This is the one that we want. So down here we've got 5, negative 2. C is 4, 2 up here. So it's 2, 4, 4, 2, 2, 4. So this is the one that we want. 2, negative 4. 90 degrees clockwise. Then last but not least, B, negative 4, negative 2. So this is 2, 4, 4, 2, 2, 4. We want this one. 2, negative 4 in quadrant 2. Label our points with our prime notation. So all 6 points should have letters. And we're done. Let's do one last problem, but let's not graph a single point. A, negative 1, 5, that's up here. So the order of our points goes 5, 1, 1, 5, 5, 1. Here we've got negative 2, negative 3. So that gives us 3, 2, 2, 3, 3, 2. And then 3, 4. So we have 4, 3, 3, 4, 4, 3. Mind you that the negatives haven't been assigned here. We're just getting the order of it down. All right, so A is in quadrant 2. I want to rotate it 180 degrees. So that is 2 quadrants worth of motion. So it's going to go from 2 to 1. It's going to end up right here in 4. So that tells me that my coordinate point's 1, 5, quadrant 4, where the y's are negative. Starting here, 180 degrees lands them here. And in quadrant 1, nobody is negative. And then from 3, 4, lands them right there. Keep it in the same order. But in quadrant 3, everybody's negative. And that is our rotations.